I was gonna say,
All right, we are recording Thursday, September 3rd.
Almost one whole week of school through.
I know. Happy Friday Eve.
Wait, we don't have school tomorrow with you. We don't have class with you.
No, you don't. Unless you have my lab.
I think I have yours and Sonia's lab.
You do.
What about me?
You don't. I won't see you till Tuesday. It is statistics class at WSSB. All right, so your homework assignment. You want to take a look at that? You had to, each one of you got to decide what question we're going to ask 10 random people, gather the data, and analyze it, doing your central tendencies, your range, your lower quartile, upper quartile, interquartile range, the factor of 1.5 to that, and then do you have any outliers or not? And if you do have outliers, then you had to redo your central tendencies, right? Okay, so who wants to go first?
I want to hear Baker's first.
You want to hear Baker's?
All
right.
My question changed.
What was your question?
How many stuffed animals did you have as a child?
How many stuffed animals did you have as a child? All right.
Mr. Face said one.
Now, hold on. I want to ask you some questions around this question and your sample. So you went to ask 10 random people.
Yep.
Did you just decide it would be absolutely random people, or did you want to look at a particular population, like only adults or only students, or
I asked
adults that are 35 or older, or students that are 15 and younger? What did you decide?
Well, I asked Miss Steinbach.
Okay. So
I asked a lot of people.
It was
totally
completely random. It was a random population of the school.
There was nothing.
All right. Okay. So you asked them how many stuffed animals did they have as a child?
Would you like me just to give you the numbers or the people who said them?
Okay. No, you don't have to give me the people, because really when we do statistical analysis and
experiments,
we try to keep our sample, our subjects anonymous. Okay. Confidential. So we wouldn't want to, but if you wanted to tell me if you were surprised by the number of stuffed animals that somebody had, and we could laugh about it. No, just kidding.
I'm surprised Mr. Face only had one.
Oh, Mr. Face only had one stuffed animal?
Mm-hmm.
Aww. All right. So what was your data that you collected? What were your elements?
1, 3, 5, 35, 40, 50, 75, and 87.
Somebody knew they had 87 stuffed animals?
Well,
that is a collector of stuffed animals.
Let's just say an average stuffed animal costs $10.
Yeah.
$870 just in fur and stuffing.
Exactly.
With tax, so $900.
A fake fur.
A fake fur, stuffing, and plastic eyes.
Synthetic fur. $900. Just laying there. Leave it to the financial algebra student to determine that in a moment's notice there.
What's it saying? Even $1,000, but some cost more than $10.
That's right.
Oh, yeah.
Got $1,000. Okay. All right, I like the commentary. Okay, that's what you're going to find that out too in statistics, like the things that we will study, or we'll just kind of it'll blow your mind. You'll be like, really? Somebody asked that question and then that was the result? Like, oh my God, like you do that. It really opens your eyes up opens your mind up to,
thanks.
Oh my gosh, wow. Somebody had 900, well, let's just round it, $1,000 worth of stuffed animals just lying there, stuffing and fake fur and plastic eyes.
Yep, that's it.
All right, and on our video, we're hearing jelly beans and Doritos. It's like the background noise. It's all good. All right, okay. And Tanner's Skype sounds. Now, you do know if you're like sitting in a college class or something, you would not want that doing that, right?
No.
Okay. All right. Okay, 1, 3, 5, 35, 40, 50, 50, 50, 75, 87. All right, what did you analyze about all this?
Well, my mode was 50, of course.
Yep, mode was 50. That means what? What does
That
mode
means
mean?
Most common repetitive number.
Yeah, excellent, Perez. Yep, one that's most common. So 50 had more influence on your data set than any other number, right? Okay. All right. What else did you analyze?
Well, my median was 36 point. Was 36 actually? I should just say was.
Your median.
No, my median was 37.
No, your median was 45. You wrote down on your homework 45.
Oh yeah, that's right.
Because if we go in, we get to a 40, and we go in from the right, we get to a 50.
Yeah, that's right. 45.
So 45. Okay. Yeah, I'm looking at your homework too. You're trying to remember it from your head. You probably should have it pulled up, but I'll let you off the hook today.
My mean.
My
mean was everything added together divided by 10.
Okay.
Which is 38.7.
It was 32.1.
Why did it
I think.
No, it's 38.7.
Oh, was it? You wrote down 32.1.
It might have been. Yeah.
Let's double check the math here. Let me pull up the calculator real quick. All right. 1 plus 3
Baker, may I
plus
ask
5
you,
plus
was it a student or a staff
plus
member at
40
87
plus-
Stuffed Animals?
Student.
96 divided by 10. I get 39.6.
Yeah, my math was off. That's.
All right.
I figured as much.
I heard you doing it in your head a little bit, so it's always good. You can check statistics. It's okay to use the calculator, people. We do not do this stuff hardly in our heads anymore because we got a lot of numbers we're dealing with. All right.
Well, yeah.
And we want to be accurate.
My
Okay.
computer calculator. I don't know how to use it.
Okay. All right. Then what did you figure out?
I figured out that I had no outliers. I didn't have to do anything.
Right. How did you figure out that you had no outliers, though? How do we figure that out? Perez doesn't know.
I took 40. 40 is. Oh, I have to tell you the median, the medians for my other. I divided the numbers into two sets of 5.
Right. And what do we call those 2 sets of 5?
Upper and lower quartiles.
Right. So Eric, when you have a data set, you split it down the middle at its median.
Medium.
It's talking
The middle
those.
size.
You split down the median, the middle, and to the left of the median is the lower half of the data, and to the right of the median is the upper half. And in those lower halves and upper halves, there is a median of those, a middle of those. And the middle of the lower half is called the lower quartile. The middle of the upper half is called the upper quartile. Okay, so what did you find for your lower quartile?
I found that the median for that would be 5.
5, good. And your upper quartile?
50.
50, okay. So then what did you do with those numbers?
Well, I have to minus my lower quartile from my upper quartile,
Okay,
and I got 45.
all right.
Times that times 1.5,
Okay,
and the easy thing you could do is just take 45, split it in half, and add it to 45 itself.
okay,
And I got 67.5.
all right.
And then I did the same thing with my upper quartile.
Well, no, you just do the interquartile range, and then you got to multiply your interquartile range by with the factor of 1.5, and you got 67.5. Now, what do you do with that 67?
You have to add 50 to it.
Add 50 to it for your upper quartile, so that'd be 117.5. And then what do you do with the lower quartile?
You have to minus 50.
And so it's below 0, isn't it? So,
So
it's less
that's
than
no
0.
logical. Yeah.
Yeah, you're not going to have negative stuffed animals.
Nope.
Unless they get
Okay.
taken away from you.
All right, so
Yeah.
why do we figure out that 117.5?
Because we need to know if there's outliers or not.
Right. And how do you know if there's an outlier based upon that 117.5?
If the number's over that.
So 87 is not anywhere close to 117.5, so it's not an outlier.
No, it's
And
not.
now
No.
Eric asked earlier, what the heck's an outlier? Well, yeah, I don't think he said heck, but I'm putting that in there because it sounds, serious.
An outlier is a number that defies normality of a statistic data set.
So it's way out there.
This individual doesn't have 117 yet.
Yet. If they have 87, what is the probability? Now we get into probability around statistics.
I'm guessing
What is the-
2 years.
what is
They'll be at
Right,
107.
well, yeah, if you know their age now and how many, you'd be like, yes, you could do it. Just on this one element in this one person, you could
Baker,
probably
do you know
do
their
a whole
age?
nother study.
You know their
14.
age? What?
14.
14. So 87 divided by 14. What will that be?
Yeah, that's 4 times 4 is 66. 5 times 14 would be 70. So 6 times 14 would be 84. So they've gotten about 6 stuffed animals a year.
It sounds like they spiked up a little. Probably since
Probably, right. You're right. It's a curve, isn't it?
Yeah, it's what's
It's
that
not
plot?
a linear.
What's that plot last
Yeah,
year?
the parabola.
The parabola hasn't gone down yet.
Mm-mm.
Still making the.
Making its way up.
We could make this a parabolic. We could do a quadratic on
So
there.
let's say I'm guessing 2 years out of 120 stuffed animals.
Yeah, okay, you're gonna predict 2 years. All right, we'll keep track of our sample and we'll ask them in 2 years.
It's Steinbach's link student in MATLAB.
Little Julia.
Yep.
Yeah.
107.
She is adorable.
I know.
Oh my God, she has the teeny tiniest little voice. She sounds like she's 3 or 4 years old. She looks like she's so tiny. Nathaniel, has Steinbach told you what she looks like?
Mm-mm.
She's this little teeny tiny thing, and she sits at. She's at the table, and the braille. Her little braille notes in front of her, and her chin is on the braille note. It's like she's got her little hands up here.
How tall is she?
I don't know, but she's just tiny, and
Is
she's
she
a
shorter than
freshman,
Stormy?
right? I think she is.
Whoa.
Yeah. She looks like she's shorter than Stormy.
Why doesn't she put books on the chair?
I don't know. She needs a little booster. Maybe she does. But she's adorable and she's funny. And
I know. She figured out fractions faster than I could.
yeah.
I have no idea.
She's just smart and funny, and she's in Steinbach's math lab. And
Her
anyway.
laugh is awesome.
So that makes sense that she would have 87 animals. It's just the way she is. Yeah. But she's funny. I like her, and I've only heard her from over here.
We need to do a big
And
probability.
I needed to know, I heard this voice, I'm like, is Steinbach teaching a kindergarten kid or something? What's going on? So I go over there and I look and I'm like, hello? And she does kind of look that way too. She's just tiny, but it's because of her health stuff that she's had to deal with that's caused that. But she's just got the brightest little personality. But it doesn't surprise me that she's the one with 87. All right.
I'll tell her that
you
predicted.
are right, Baker. All of that is correct. You put your data. I noticed that you put your data set in order.
Yep.
You correctly identified the mode, the median, the mean. Well, the mean got a little off, but that was your mental math. You found your lower half, upper half, and found your lower quartile, upper quartile, did the inner quartile range, did the factor to find your outliers, discovered, hey, no outliers, and so you were able. Now, one more thing you needed to find. And you did, on your homework. So you did no outliers, and then you need to identify one more thing.
Range.
Range. Right. So,
Thanks, Tanner.
And on your homework you said 86, and that's correct. The range is the difference between the...
That's a huge range.
It is a huge range. It's interesting with that big of a range
But there's no
that
outliers.
there isn't an outlier. However, because of the mode at 50-50-50, you see how that kind of pulled it in,
Yeah.
right? And so that 50-50-50 kind of balanced
If
out.
the 50s were dropped to 40, it might have been a.
It might have, right? Or maybe even 30, we might have created an outlier. But so your mode is at 50, your median's at 45, which is close to your mode. Your mean's at 39.6, which is around 40, which is kind of close to that median and mode. So that all should make sense.
I should have done something a little bit more logical, because I don't think a lot of people can remember the actual number.
Yeah, that is true.
I was going to say, how many people actually go through
I think
and
your
count?
50s were probably estimates. You
Like
know?
shout-outs, yeah.
Yeah.
I figured the same thing, but I wasn't gonna
Doesn't
argue.
matter. It's all good. But you learned from that. That's your reflection now on your reflective practice on what you did, right? You designed this little mini question, this little survey, and you realized, oh, my question probably wasn't, I probably would figure out a different question, or I would ask it differently, or I would ask, can you please, go to your house tonight and count your stuffed animals and report that to me tomorrow. You might have instead of just an estimate. Right, they might not even add them. So then you'd be like, well, maybe I should only ask people that have stuffed animals currently. I don't know.
Well,
So-
an interesting would have been is to ask 10 adults and then ask 10 students and see how it's gone up.
Yeah, the difference, right? 10 adults, 10 students. Mm-hmm.
You
And
see,
is your prediction that kids nowadays have more stuffed animals
or more toys.
or more toys?
Get
Yeah.
adults from age 30 to 50.
Mm-hmm.
Definitely less stuffed animals.
You think?
I know.
Well, the kids back then got 120, they're happy forever. Now all these kids just need a smartphone and they're happy forever.
I know, it's true. Yeah, the technology has changed.
Because you can download as many apps as you want.
So you're starting to think about, statistics is about looking at things across different years or across different generations and comparing and predicting, right? And wondering why, and then using that to maybe predict in the next, like you already did a little mini prediction, with like the 187. You said, well, probably on the curve, she's going to slow down a little bit when she sped up, but she could still be in the speed up because she's only 14. She'll eventually top off.
16's probably
and then she's probably going to decline. And then you're right that it's very parabolic.
Well, maybe then it will go below 0.
Yeah, it might. Yes, you might get rid of her stuffed animal. It'll go to 0. You can't have negative stuffed animals.
Well, yeah.
Yeah, it wouldn't cross the X.
Well, yeah. Well, if you start at 87,
right,
you can go below that and go to 0.
Right, you could get to 0.
Yeah.
She could get rid of some of her stuffed
like
animals.
87 is the starting point.
Right.
I knew she had more.
She just couldn't remember. She just figured she had about 87. All right, Tanner, what was your question?
How many different schools have you been to in your life? And
Okay.
I only asked students.
Okay, so you clarified your sample. So how many schools, okay, in your life? And you said you decided that you were going to keep your population, that you were going to sample only to students at WSSB.
It was surprising, the range, the amount.
Yeah. Okay. So what was your data set?
2,
Mhm.
2, 3,
Mhm.
3 4s,
3 4s. Okay.
5,
Mhm.
6, and 2 7s.
And 2 7s.
What?
Yeah, a lot of. 4 sounds about right to me.
Yeah.
This should be a good and even preschool, elementary, middle school, high school.
All right. If you just kind of stay in that, but if you move around,
Like
Don't forget
7.
about upper elementary.
yeah. What's that, Eric?
Don't forget about upper elementary.
An upper elementary sometimes. Yeah. Sometimes kids split
Middle.
lower and upper.
Yeah.
Yeah. All right. So 2 2 3 4 4 4 5 6 7 7 is your data set.
Yes.
Okay. What did you discern from your data here?
Well, I did the outlier thing.
Okay, you calculated outliers. So how did you calculate your outliers?
Well, I went down between the 4s.
Okay.
So there's 4, 4, and
Mm-hmm.
in the middle of 4s, 4.
Okay.
So then I went over, and the lower quartile is 3,
Okay.
and the upper is 6.
Okay.
And the inner quartile range is 3.
Yep.
So then you times that by 1.5,
Okay.
which is 4.5.
Okay.
Then you subtract 4.5 from 3.
Okay. Go to negative land.
And-
Can't go to negative school.
Yeah.
Okay.
Unless you're not even born.
Okay.
And then you add in 10.5. If
Okay.
you've been to 10 different schools, you
Yeah.
need some help.
Well, you moved a lot.
Yeah.
So 10.5 is your upper end. All right. So do you have any outliers?
No.
No. Okay.
So then I went back up to the top and did the median range.
Okay. All right. Your median.
4.5.
All right. 1 2 3 4. 1 2 3 4 5. 1 2 3 4 5. I just get 4 because you have 2 4s in the middle.
Oh, yeah.
Okay. All right. Okay. Next.
Oh, the mode,
Uh huh.
4.
Okay.
Range, 5.
The range is 5. Okay.
And mean is 4.4.
4.4. You added them all up. 2 and 2 is 4. 3 is 7. 4 is 11.
That's
4
a
is 15.
44.
19, 24, 30, 44, 4.4. Yep. Okay. And lower
That's it.
quartile 3 or upper quartile 6. Inner quartile range 3. The 3 times 4.5. You'd have to have less than 0 or 10.5 to get, and so you have no outliers. Good. All right.
How many schools do you
Excellent.
think you've been to?
And then, hold on. So if you look at the central tendencies of the mean, median, and mode, they're
It's
at 4, 4, and 4.4. That's a really that's good.
On the range. It's fine.
Yeah, and the 4 range is 5.
So it's anywhere from 4 to 5.
Yeah, most of the time, yeah, your data set is pretty, the vast majority of your data is right in there in that 4 range, yeah. Or from 3 to 6, and then you got a couple in the end there. But you could, reasonably say that, according to your sample size, the average number of schools that a student has been to is around 4.
I would one of those schools, right?
How many schools have I been to? So do you have to count the whole lifetime? So that would be another thing is you decided only students because you realized if I ask adults, this could get crazy, right?
Yeah, you can transfer to different colleges. And then,
right.
I know, some
so
jobs.
My childhood, I had 2 elementary schools because we moved. I had a junior high and a high school. So I did the 4.
Oh, in preschool.
And I was at a kindergarten, a private kindergarten. You're right. So I actually had 5.
Private?
Yeah, we didn't have public kindergarten when I went to school. You started first grade in first grade, when you were 5 or 6 years old. And so I was actually 5 when I started first grade because I have a September birthday, so I didn't turn 6 until the 29th. So when I graduated from high school, I was 17.
I will be too.
Yeah, maybe then. Okay, so you're right. If I count the private kindergarten, okay, so 5 schools. Then college, I went to Mount Hood Community College first, and then I went to Warner Pacific College.
WPC.
Yeah, WPC in Portland. And through WPC, I had to pick up some classes at a college down in Salem. I forget what it was called, Cordell or something. They grab a couple classes for them. And I had to, then I think I took a class or so at PCC. I also took some more classes at PCC later. I taught at PCC, so I took classes there because you could take them for free.
And teach
I went to I went to Lesley University out of Boston, Massachusetts, but I didn't go to Boston. They actually flew the professors here, and we went to college on Friday nights, all day Saturday, all day Sunday, once every 3 weeks. And I actually did it at Harney Elementary School here in Vancouver, Washington. We would all meet there, a group of teachers, and they would fly these professors in. So Lesley University was my first master. Jill, you got it, or would you like a pair of scissors?
From Boston.
Okay, from Boston. Okay, so Lesley University. Then I did Portland State for my second master's to learn to be a TBI. So we're at 11, aren't we? And I also did Clark College because I teach there and I can get classes there for free. So I've done some math classes there.
And you learned here.
And now does this count? Now, do I also count what I taught at?
No. Have you learned things here?
Well, true, I've learned things here, but it's not an official,
No, you haven't got a degree here.
Right. So I think I'm at 12.
Wow.
And you'll be on my range.
I would be out of your range, yeah.
Right.
Well, no,
Outlier.
but if you took out one of the 7s and put a 12 in, so you still only had 10 numbers.
Yeah.
If you had 11 numbers, it still might not. It was going to mess with it, isn't it? Because your lower quartile will change and your upper quartile will change.
No, please.
No Reese's?
No, I'm just did it.
You're like, ugh, sugared out. You are going to make her.
You're gonna be.
Aren't
Okay.
you going to feel bad?
Can you pause
Yeah,
the video for
probably.
a second?
Oh, jeez, at least she'll be out of my class.
Can you
Well,
pause the
especially
video for
since
a
I
second?
haven't eaten like
What's
this.
that?
Can you pause the video for a second?
You want me to pause? Hold on.